All right, so today we are learning something brand new, yet it's very old. Now, let me ask you a few questions. Okay. Can we say that everyone knows this of a right triangle? Right? Your A, B, and C, A squared plus B squared equals to C squared. Pythagorean Theorem. Everyone knows it. Okay. I think everyone knows. Ooh, well, actually, this one I'm not sure. I hope everyone knows, but if you don't, then you need to brush up. Like if you have a right triangle, if it's a 45, 45, 90 triangle, how would you label the sides? If this is x, this would also be x, and the hypotenuse is x root 2. All right. If you're taking the SAT, you should know it, right? And I hope you should still remember the 30, 60, 90. Okay, 30, 60, 90 degree triangle. Well, if this is x, then the other leg would be x root 3, and the hypotenuse will be 2x. 2x. Okay, if you're taking the SAT soon, you should know these triangles. It is given on the reference chart, but you should really know it. You should really know it. Okay. At this point, I believe that everyone knows about sine theta, cosine theta, and tangent theta, right? No, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Everyone knows it. Okay. So that's old stuff. And what kind of new stuff are we creating based on these old stuff? Well, let's go ahead and take a look at this point. All right, so 1, 2, 1, 2. So if I put a point right here, what would you label this point with, like in terms of the XY coordinate system? 2, 2, right? Easy. And if I say, all right, guys, let's go ahead and draw a line from the point to the origin. Can you tell me the length of this blue line right here? Louder. 2 root 2. Okay. You can either do a Pythagorean theorem, or you can just say, oh, hey, I can see a little isosceles triangle, the 45, 45, 90 triangle. You can get 2 root 2. And let me say this. Can you tell what this angle is? What is this angle? 45 degrees, right? Or in radians, we call it pi over 4. Pi over 4. Okay. So now, so these are all old stuff. You know how to figure these out. And we're going to collect these bits and pieces. And we say, all right, what's the new stuff? We are going to convert the rectangular system with x and y to something called polar system, that it's with r and theta. What's r? Well, what could r be? Radius. Radius. So in this case, this will be 2 root 2, comma, pi over 4. Easy? Very easy. Okay? Very, very easy. So we're not doing anything new. It's just something that we say, oh, yeah. A different way of presenting it. Now, I will show you the need of a polar system in a short moment, but that's just a change of the presentation. Now, if I present you another situation. All right, so we have this line right here. All right, and we call it y equals to x. Okay, y equals to x. You learned it from algebra 1. Hey guys, what's this angle right here? If it's y equals to x, well, what's this angle? 45 degrees, right? So that means pi over 4. Now, if we say, hey, we have a challenge right here. We've changed the point from rectangular to polar. Now, how do we change the equation from rectangular to polar? Well, this is y equals to x, right? And now, a lot of people, they kind of forgot this. I want to bring it back up again. Back in elementary school, did you learn this thing called like a line is composed of infinite points? Points, okay? A line is composed of points, right? So this little line y equals to x is actually composed of many points. And now, and if you understand the idea of r and theta, r, which is the distance from the origin, theta is the direction. So if you think about just this part right here, can you see that all of the points over here, all of the points over here, they all process the same angle, right? Same direction at pi over 4, but at different radius, or different radii. And then what about these part right here? Well, it goes to the opposite direction, right? So we can say, well, it's the same angle, but in opposite direction. So this is actually the polar equivalent of the equation, y equals to x. It's telling people that, hey guys, you know, it is in this angle, but what's the radii? Oh, all kinds of radii. Okay, because they're all the points. Now, to give you a better perspective, let me give you a little identical example here. If I draw a horizontal line right here, and this is y equals to 3, what do you call this equation? Y is equal to 3, right? If I ask, hey guys, how come there's no x in this equation? How come there's no x in this equation? Because? Huh? No? Because, well, what could x be on this line? Anything. And anything will work because all the points right here, they all share one thing common. Y coordinate must equal to 3. What's the x? X is anything. You name it. So that's why we don't see the x in the equation. So why don't we see r in this equation? Because r could be anything. All right, so that's what we are going to see in our polar coordinate system. Again, it's about which direction you're heading to and how far you're going to walk from the origin. Okay.